notes for chapter 23 over t-distributions. Got your 84s, got the notes. Make sure you have the recipe for success, just like I made it for you for the other chapters. Have both outlines. That way it makes it easier for you. So hold on to these because I already made them two-sided. I made them on the front and the back, so you should be able to use this for the quiz and the test. So hold on to them, okay? So this is actually pretty simple because a lot of this is actually pretty much the same steps as you already did for when we ran a z-test for the data that we were given. So I'm just going to explain the differences and just go through one again with you, kind of step by step. But you're going to see a lot of the steps are the same. You're still going to be running the hypothesis test. You're still going to be finding confidence intervals. The only difference is when we looked at z-test, this is the equation for that. Okay, you're given, this is the equation you used last chapter. Because last chapter, you were given the population standard deviation. So you were given this number, okay? So the difference in this chapter is you're not. So you don't know what the population standard deviation is, so you're not able to use this equation to run your hypothesis test. So instead, really the only difference is you're given a different equation to apply. So you still have to figure out the sample average. You're going to be given the population average. You're still going to be given n. So instead of a population standard deviation, you're going to be given a sample standard deviation that you're going to have to figure out. So because of that, your data is not really as exact as it should be because if you kind of glance at the first problem, okay, now on these questions, you're actually going to be given some data that you're going to have to be using. So because of that, before, you weren't given a lot of information. Most of the questions you worked on, you weren't given some data. So because of the reason being that you were given a sample, they were already giving you the sample average, and they were giving you the sample average and also the population standard deviation. So now they're not giving you those two things. You're going to have to find them out from entering your lists into your 84 and figuring that out. So because you're having to do that, you're getting that information from like a sample size of like 24 students. So the information that you get is good because you can use it, but it doesn't really reflect like as accurate as it should be. So what that causes is it causes your curve to not be distributed exactly the way it should be, like as accurate as it should be. So it causes like a little bit of skewness or a little bit of gaps in the curve from what it should look like because you're just using a set of sample numbers. So the term that you may see when you're running when you're trying to use a confidence interval is degrees of freedom. So really all that term stands for is it's like the variance that's caused by, it's the variance of each number that it's caused by you using a sample and not actually like the population numbers. So, I mean, it only makes sense if you're using information from a sample, then of course your data is not going to be reflected as accurately as it should be. So it causes a little bit of variance, a little bit of differences, and that's what we call degrees of freedom. So the more you increase this, the more closer your information is actually reflected with the curve, by the curve. But if you glance at your recipe for success, I mean, all the steps are pretty much the same, except now you're just dealing with a different equation, and the only difference is you're going to see a different letter for this. Okay, now it's going to be an S instead of an O because this reflects the population standard deviation. That's not given to us anymore. So we're going to be figuring out the sample standard deviation from our information that we're given. So when you read through these questions now, pretty much the only thing you're going to be able to get from the problem by reading it is your sample size and maybe the population average, okay? And that's pretty much it. Your sample average and your sample standard deviation you're going to have to get from entering these numbers into your 84 and getting that information from those. So we'll just go through one together. But, I mean, a lot of the steps you're going to recognize, they're pretty much all the same. So again, I'm just going through this little cheat sheet that I got you. So number one, so basically it's telling you that a professor um, thinks, or pretty much is kind of assuming that he thinks about the average number of credit hours that students take at a university is 15, which is kind of traditional. So he takes a random sample of 24 students, and he wants to see, or basically asking, does the sample indicate that students are taking more than the professor believes? So that's kind of a key word and indicating, that's a key word that's going to help you determine your alternative hypothesis. So your null hypothesis is that your average is equal to 15. That's what he believes that the average number of hours a student takes is. And the alternative that you're going to be testing, kind of the same way you already did for z-test, you're trying to see if the kids are actually taking more than what he believes. So you're going to use the greater than symbol. So it's going to be greater than 15. Okay. So look for keywords to help you determine what inequality to use for your alternative. Number two, same step, you're going to define the parameter. So for your parameter, where are you trying to find? So it's the true population mean. Okay. What should you say? Like for the average number of hours a student takes. So the true population mean for the average number of, I think it's semester hours, or per term. So the average number of hours per term. Okay, so per term. Okay, so make sure, I think by now, because I went through your homeworks, your quizzes, and I made a lot of notes for each of your problems. I think by now, you've cleaned up your work a little, like you're not missing the little details in how you write these answers out. So step 3, write the equation. So now it's just a different equation. Okay, it's a t equals x bar minus mu over s over the square root of n. Okay, so it's like this. 3 of the 4 letters are the same, except you're given a new letter s. So it's to represent the sample standard deviation. That's the only difference. 4, you're gonna graph and shade. So same way you've done. So you're gonna draw the curve out, and then you put the average in the middle. So that's 15. Okay, then you're gonna be shading off to the right. That's what you're trying to test to see if it's actually greater than that amount. 5. It says enter data if given. So now on a lot of the questions you are going to be provided data because you're having to figure out the average from the sample and also the standard deviation from the sample. So I guess now if you want to, you can say, okay, data is given, because before you were stating that it wasn't. Okay, and at this point is where you'd want to enter that information into your list. So coming from a blank screen on the 84, you go to stat, and these steps are written out off to the right. So you go to stat, edit, and then you put all those numbers down one of the lists. Okay, doesn't matter what list. Usually you just use list 1 because it's pretty standard. They're already set. So I'll do that over here because I can do it a little faster than typing it out. So there's a 12, 13, so 2 14s, 3 15s, okay, and then 4 16s, and then, actually 5 16s, I'm sorry. So 5 16s, 3 17s, okay, and then 4 18 hours, so 18, 18, 18, 18. Okay, and then 3 19s. So 19, and then a 20 and a 21. Okay, so I mean, if you wanted to, you could count, but you should have 24 responses. Okay, because there's 24 numbers total. So once you have them all entered, you go to stat, calc, and you run a one variable stats test. So make sure you just choose list 1 because that's where you put all the numbers under. So you hit calculate, and So the two things you really want to get from doing this, you want to get X bar, okay, because that's a sample average, so you want to jot that down somewhere. And then the other number you want to get is this SX, okay, because SX is your standard deviation from the sample, so you want to write those two numbers down somewhere. So 16.625 and 2.223. Okay, those are two of the four numbers you need. The other two are already given to you in the problem. Okay, and that's kind of n equals to 24. Okay, you should have had 24 numbers. So if you saw like 23 or 22, then you missed a number. Okay, so for step 6, that's where you're defining the numbers. So step 6, your population average was 15. Your sample average was 2.223. Okay, X bar, not your sample average, I'm sorry. Your sample standard deviation was that. Your sample average was 16.625. And then there were 24 people that the professor surveyed. So n equals to 24. Okay. 7, you're plugging, okay, these numbers into that equation now. So same thing. So it's going to be T equals 16.625 minus 15 over 2.223 divided by the square root of 24. Yeah. So you're just plugging them in. Like I personally would not try to calculate this because there's a test that gives you this number already. So just plug the numbers in where they go for this step, and then for step 8, that's where you're figuring out your T and your p-value. So to get both of those numbers, before we would come over here and we would run a z-test, okay? But now, if you go to stat, test, so before we would choose option number 1, but we're going to choose option number 2 now because we're running a t-test, a t-distribution. So you hit enter, highlight stats, and then it's kind of the same process. You just fill in the numbers that you're entering. So that's 15. And you'll notice that some of the numbers will already be inputted because you've entered numbers into a list. So like your sample average is already there. The sample standard deviation is already there. The number of numbers you've entered into the list, it's already there. So the only thing you had to enter was your population average. And then you choose the greater than symbol because that's what you used on your alternative test. And you hit calculate. And the two numbers you need from here is the t equals and also your p-value. So you want to jot both of those down for step number 8. Okay. So just keep in mind that p is in scientific notation. So you have to move your decimal 4 places to the left. So basically, you're going to have 3 zeros basically in front of p. So for 8, t equals 3.581, and your p-value was 0.0007 when you move that decimal place over to the left 3. Okay. Step 9 is where you compare your p-value to your alpha level. Okay. So so p was equal to 0.0007. So they didn't give you a significance level at the top of the problem. They didn't give you an alpha level. So you compare it to 0.05. Okay, the same way we did previously in the last chapter. So clearly this p-value is smaller than your alpha level. Okay, so you're going to come up with that same conclusion as you did for step 10. So since your p-value is less than alpha, you're going to reject the null. Okay, so you're going to follow that template, the first template that you see. So you'd say, okay, our p-value is 0.007. Okay, we reject the null. There is sufficient evidence at alpha 0.05 to suggest that the true population mean for the average number of hours per term is, and you say what? Because what I've noticed, like on the tests or the quizzes, you're messing up the last part of that format.